Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
For this question, we're considering a copper cube. The length of each side of the cube, L naught, is 0.3 meters. And then we subject it to two shear forces, each of which has a magnitude F of 6 times 10 to the 6 newtons. We're asked to find the angle theta in degrees by which the block is deformed. S here is the shear modulus, and this is going to be equal to, since we're dealing with copper, 4.2 times 10 to the 10 newtons per meter squared. And of course, the area, since it's a cube, is just the length of each side squared. So it's 0.3 meters squared, which would be 0.09 square meters. Okay, so the shearing force that's exerted on the copper cube is given by definition F, and it's equal to S times delta X, which is what we're trying to find, the compression amount, divided by the original length, L naught, multiplied by the cross-sectional area of the cube, A. So rearranging this to solve for delta X, which we're going to need to find the angle, we find that delta X is equal to F times L naught divided by S times A. Plugging these values in, we find a value for delta X equal to 4.76 times 10 to the minus 4 meters. So if you look at the graph that we're using for this question, you can determine that since there's a right angle here, you can determine that this allows us to use a trigonometric identity since the tangent of theta is the opposite over the adjacent, where the opposite here would be delta X and the adjacent is L naught. We can find that the inverse tangent is going to be equal to that angle. So the inverse tangent of delta X over L naught is equal to the angle theta that we're trying to find. Well, we now know delta X and L naught was given. Plugging those values in and taking the inverse tangent of that ratio, we find that the angle is 0.09 degrees. And this can be boxed in as our solution to the question.